Your brain is about to get a great workout because we are learning 3rd grade math. If you are in 3rd grade and you want to learn math, this is the place to be. So whether you're just starting out or needing to review for a test or whatever, there are tons of math topics here to get you where you need to be. And of course, we're going to have fun along the way. First, let's learn about multiplication, okay? Multiplication. And we should start with this question. What is multiplication? Well, multiplication is when you have a number a certain number of times. For example, a standard bike has 2 wheels. But if there are 2 bikes, then you have the number 2 times. In other words, 2 times 2. That's multiplication. This x tells us we're multiplying. The number 2 times is the same as 2 plus 2. It's the number 2 twice. How many wheels are there in all? What's 2 times 2? Yeah, 4. 2 times 2 equals 4. There are 4 wheels in all. You know, a motorcycle has 2 wheels also. Whoa, here are 3 motorcycles. To find the total number of wheels, we have the number 2 3 times. 2 times 3. 2 times 3 is the same as 2 plus 2 plus 2. It's the number 2 3 times. What is 2 times 3? Yeah, 6. There are 6 wheels in all. 2 times 3 equals 6. There are a total of 6 wheels when you have 3 motorcycles. Great job. Cookies. Yeah, let's practice multiplication with cookies next. Let's say a store sells boxes of cookies. There are 3 cookies in each box, and someone buys 3 of these boxes of cookies to enjoy with some friends. Now, to figure out how many cookies there are in all, you would multiply the 3 cookies times 3, because there are 3 boxes. 3 times 3. This is the same as 3 plus 3 plus 3. It's the number 3 times. What is 3 times 3? 9. Awesome! 3 times 3 equals 9. That means there are 9 cookies in all. 3 cookies 3 times means there are 9 cookies. We could even count the cookies to double check. 3 cookies 3 times. 1, 2, 3, 4, 5, 6, 7, 8, 9. 3 times 3 equals 9. I don't know if I've mentioned this in any of my videos, but I love basketball. It's my favorite sport. I was obsessed with basketball as a kid and collected basketball cards. Actually, I still have my basketball cards. I keep them in my office and still look at them from time to time. They're really cool. Now, why am I sharing this? Well, when you collect cards, you're used to using multiplication. Let's say a new series of basketball cards has 6 cards in every pack. Every pack has 6 cards. And I have enough money to buy 3 of these packs. To find out how many cards I'm getting in all, we have to multiply 6 times 3. It's the number 6 3 times. This is the same as 6 plus 6 plus 6. It's the number 6 multiplied times 3. What is 6 times 3? Yeah, 18. Great! 6 times 3 equals 18. I'm getting a total of 18 cards. We can just double check that real quick. 6 times 3 means we have the number 6 3 times, which is the same as 6 plus 6 plus 6. 6 plus 6 equals 12. Yeah. And 12 plus one more 6 is 18. Yeah. 6 times 3 equals 18. Let's try another one. What is 8 times 1? What is 8 times 1? Yeah, 8. 8 times 1 equals 8. Now, why is that? Well, if you have the number 8 just one time, you just have 8. Actually, any time you multiply a number times 1, the answer is that number. Going back to bikes, you know that a bike has 2 wheels. If you have one bike, to find the total number of wheels using multiplication, you could multiply 2 times 1. 2 wheels, once. The number 2, just one time. And what's 2 times 1? Yeah, 2. 2 times 1 equals 2. If you multiply any number times 1, the answer is that number. For example, 9 times 1 equals 9. It's 9 just one time. 12 times 1 equals 12. It's the number 12 one time. 100 times 1 equals what? 100. It's 100 just one time. Great. Let's give this one a shot. 7 times 0. What do you think 7 times 0 is? Yeah, 0. But why is that? Well, if you have a number 0 times, you have 0. 7 times 0 equals 0. 7 times 0 means the number 7 0 times. The answer is 0. Whenever you multiply a number times 0, the answer is 0. 1 times 0 equals 0. It's the number 1 0 times. 5 times 0 equals 0. It's the number 5 0 times. 10 times 0 equals 0. What is 1 million times 0? You got it, 0. Awesome job. Aw, look at these puppies. Come over here, puppies. We're going to practice more multiplication. Come on. Hey, let's try this one. What is 4 times 2? What is 4 times 2? Yeah, 8. 4 times 2 equals 8. Great job. 4 times 2 is the number 4 2 times. This is the same as 4 plus 4. It's 2 4s, and 2 4s equals 8. 4 times 2 equals 8. Okay, let's try 5 times 3. What is 5 times 3? Yes, 15. 5 times 3 equals 15. Sweet! 5 times 3 is the number 5 3 times. This is the same as 5 plus 5 plus 5. It's 3 5s. 5 plus 5 equals 10. Plus another 5 is 15. 5 times 3 equals 15. Next, let's try 1 times 4. What is 1 times 4? 4. Very cool. 1 times 4 equals 4. If you have the number 1 4 times, you have 4. You might have picked up on this already, but with multiplication, the order of what you are multiplying doesn't matter. The answer is the same. 4 times 1 equals 4. 1 times 4 equals 4. If you flip the 4 and the 1, the answer is the same. The answer is 4. I'll show you with pizzas, okay? Let's say there's going to be a big party, right? And a pizza place has a 4 pizza deal. It's a special deal that gets you 4 whole pizzas at a lower price per pizza. You get 1 4 pizza deal. It's 4 times 1. The number 4 once. 4 times 1 equals 4. So you have 4 pizzas. Now, if you flip the order and switch the 1 and 4, the answer is the same. See, this is the same as if you multiplied 1 pizza 4 times. That would be 1 times 4 equals 4. Both work. You can flip these numbers in multiplication, and the answer stays the same. Oh, it's question time. It's question time. I have a question for you. What is the answer to a multiplication problem called? What is the answer to a multiplication problem called? Yeah, the product. The answer to a multiplication problem is called the product. For example, 5 times 2 equals 10. 10 is the answer, so it's called the product. 0 times 6 equals 0. 0 is the answer, so 0 is the product. The answer to a multiplication problem is called the product. Let's go ahead and look at a few more. What is 3 times 4? What is 3 times 4? Yeah, 12. 3 times 4 equals 12. Phenomenal job! And as we just learned, 12 is the product. It's the answer to this multiplication problem. 3 times 4 means we have the number 3 4 times. It's the same as 3 plus 3 plus 3 plus 3. The number 3 4 times. 3 plus 3 equals 6. So each of these pairs equals 6. And what's 6 plus 6? Yeah, 12. That means 3 times 4 equals 12. Wow, we're in Egypt. That's pretty cool. That's pretty cool. Let's try 5 times 6. What is 5 times 6? What is 5 times 6? 30. Very cool. 5 times 6 equals 30. This is a big answer, isn't it? 5 times 6 is the number 5 6 times. To double check this, we can count by 5s. 5, 10, 15, 20, 25, 30. 5 times 6 equals 30. Great job! 30 is the product, the answer to this multiplication problem. Okay, here's the last one. What is 10 times 7? What is 10 times 7? Yeah, 70. Awesome! 10 times 7 equals 70. This can be illustrated using dimes because dimes are worth 10 cents. 10 times 7 means the number 10 7 times. Each dime is worth 10 cents, and there are 7 of them here. 10 times 7. To check our answer, we can count by tens. 10, 20, 30, 40, 50, 60, 70. 10 times 7 equals 70. 70 is the product. Wow, you did an incredible job learning about multiplication. I'm so proud of you. Next time you come across multiplication, you can get super excited just like this owl because you get it. You know how it works. Keep building up your skills. Multiplication is really cool, and so are you. You did great with multiplication. Well done. Now we're going to change it up and talk about the opposite of multiplication, division. That's right, division. First, we need to find out what is division. What is division? Well, division is when we split a number up by a certain number. Let's say there are 4 apples. Michael and Liam want to split the apples, and they want to make sure it's fair. There are 4 apples, and we are dividing the apples into 2 groups. One for Michael and one for Liam. 4 divided by 2. This symbol right here is the division sign. It shows us we're dividing. What is 4 divided by 2? Yeah, 2. That's right. 4 divided by 2 equals 2. If Michael and Liam are splitting these 4 apples, they each get 2. Check out this one. Let's say there are 6 bottles of water and there are 6 kids playing outside. That would be 6 divided by 6. If we split the 6 bottles by 6, how many water bottles does each kid get? 1. Great job. 6 divided by 6 equals 1. Everyone gets 1 water bottle. All right, next, let's practice division with school supplies. Let's say there are 9 brand new pencils that 3 students are going to split. 9 divided by 3. We're dividing the 9 pencils between the 3 students so that the students each get the same number of pencils. when we divide 9 by 3, how many pencils does each student get? Yes, 3. Great job. That means 9 divided by 3 equals 3. If you split 9 into equal groups of 3, there are 3 in each group. 9 divided by 3 equals 3. Awesome job. Before we practice more division, I want to ask you a quick question. What is the answer to a division problem called? What is the answer to a division problem called? The quotient. Yeah, the quotient. That's a cool word. Let's say that together. The quotient. Right. Can we say it one more time, just a little louder? The quotient. Yeah, the quotient. Okay, so we practiced 4 divided by 2, which equals 2. 2 is the quotient. We did 6 divided by 6, which equals 1. 1 is the quotient for that problem. And we just did 9 divided by 3, which equals 3. That means 3 is the quotient for that problem. The quotient is the answer to a division problem. And don't worry, Crab, we're going, okay? We have more division to do. Oh my goodness, it's somebody's birthday! Speaking of birthdays, here's a man celebrating his birthday with just 1 candle. I'm not sure what he's saying, but I like to think he's saying, "I put 1 candle on my cake." And she responds, "That's great. That's great." We're going to be dealing with more than 1 candle, though. In fact, imagine we have 7 candles. 7 of them. Now, in the other division examples, we divided a number into multiple groups. But in this example, we are only going to divide 7 by 1, because all of the candles are going on the same cake. 7 divided by 1. And the answer is super simple. How many candles does each group have? Well, there's just 1 group, and all 7 candles are on it. So the answer is 7. Yes, 7 divided by 1 equals 7. 7 is the quotient. Anytime you divide a number by 1, the quotient is that number, because all of it is going into just 1 group. For example, 9 divided by 1 equals 9. It's 9 just getting put into 1 group. 40 divided by 1 equals 40. It's 40 getting divided into just 1 group. 1,000 divided by 1 equals 1,000. It's 1,000 divided into just 1 group. When you divide a number by 1, it's super simple. The quotient is that number. Whoa, look at these 2 bears. These 2 bears are going to share some fish, okay? They're going to evenly divide some fish, okay? Whoa, bears. You both are friends. You both need to share these fish, okay? Evenly. We're going to divide them up. So there are a total of 10 fish, and we are dividing the 10 fish into 2 groups, 1 for each bear. 10 divided by 2. The quotient, the answer to the division problem, will tell us how many fish each bear gets. What is 10 divided by 2? Yeah, 5. Great. 10 divided by 2 equals 5. And you can see each bear gets 1, 2, 3, 4, 5 fish. 10 divided by 2 equals 5. Awesome job. Aw, hello doggies. Are any of you hungry? I'm asking because, well, I have good news for the 4 of you. We have dog biscuits for you to share. We just want to divide them evenly so each of you gets the same amount. We have 12 dog biscuits here. 12 of them. And there are 4 dogs. 12 divided by 4. We have to divide or split up the 12 dog biscuits into 4 equal groups. 12 divided by 4 will tell us how many dog biscuits each dog will receive. What is 12 divided by 4? 3. Great job! 12 divided by 4 equals 3. Each dog will get 3 dog biscuits. 12 divided by 4 equals 3. 3 is the quotient. You are doing an incredible job. Let's try this one next. How many people do you see here? 5. There are 5 people who have been playing outside and are going to take a quick snack break. Thankfully, they brought strawberries. They have 20 strawberries in all and want to divide them amongst each other. This will be fun. So there are 20 strawberries in all, and we are dividing them into 5 groups, 1 for each person. 20 divided by 5. What is 20 divided by 5? Yeah, 4. Awesome! 20 divided by 5 equals 4. That means each person gets 4 strawberries. 20 divided by 5 equals 4. 4 is the quotient. Great! Hey, I think it's time for a division fact. It's division fact time! When you have a division problem, the total number is called the dividend. The number of groups you are splitting it up into is called the divisor. And the answer, as we've already talked about, is called the quotient. Now, a cool thing about division is you can switch the divisor and the quotient, and the division problem remains true. For example, 8 divided by 4 equals 2, but also 8 divided by 2 equals 4. Interesting. The divisor and the quotient can be switched, and the division problem remains true. I'll show you with bananas. Bananas are so tasty! We have 8 bananas here. 8 divided by 4 equals 2. Dividing the 8 bananas into 4 groups means each group has, 2 bananas in it. Cool. Now, if we flip the 4, which is the divisor, and the 2, which is the quotient, it remains true. So 8 divided by 2 equals 4. If we divide the 8 bananas into 2 groups, we see there are 4 bananas in each group. That's pretty awesome. And speaking of awesome, the next example is from the world of tennis. Have you ever played tennis before? Okay. I enjoy tennis. It's a fun sport. Let's say there are a total of 16 tennis balls, and 2 tennis players want to split them up. 16 divided by 2. 16 divided by 2 will tell us how many tennis balls each player will get. What is 16 divided by 2? 8. There are 8 tennis balls in each of these 2 groups. 16 divided by 2 equals 8. Okay, so 16 divided by 2 equals 8. Now remember, the total we are dividing is called the dividend. The dividend is 16. The number of groups you are splitting it into is called the divisor. The divisor in this division problem is 2. And what is the answer to a division problem called? The quotient. Great job! The quotient in this problem is the number 8. Now, we learned that we can switch the divisor and the quotient and it remains true. Let's put that to the test with this. We'll try 16 divided by 8, which will be 2. Here are the 16 tennis balls again, but this time we'll divide them into 8 groups because the divisor is 8. In this case, 8 players are splitting the 16 tennis balls. How many are in each group? 2. 16 divided by 8 equals 2. Fantastic job. So you really can switch the divisor and the quotient and the answer remains true. That's really cool. Okay, let's look at a few final division problems. If you don't know the answer, that's all right. Division can take practice and you'll learn a cool new division fact for next time. Here's the first one. 9 divided by 9. What is 9 divided by 9? Yes, 1. 9 divided by 9 equals 1. If you have 9 and divide them into 9 groups, there is 1 in each group. 9 divided by 9 equals 1. 1 is the quotient. Great job! Here's the next one. 14 divided by 2. What is 14 divided by 2? 7. 14 divided by 2 equals 7. If you have 14 and divide it into 2 groups, each group has 7 in it. 14 divided by 2 equals 7. 7 is the quotient. Fantastic. All right, here's the last one. What is 15 divided by 3? What is 15 divided by 3? Awesome, 5. Yeah, 15 divided by 3 equals 5. If you have 15 and divide it into 3 groups, each group has 5 in it. 15 divided by 3 equals 5. 5 is the quotient. You did such an amazing job. Even if you didn't know all of these, you are well on your way to being a division master. Amazing job learning about division. Whoa! Okay, what does this beaver have to do with any of this? I'd love to get back to math if we could, okay? Great, okay, great. I think we are ready. Now we are going to learn about something related to division. Fractions. That's right, fractions. It's fraction time. I love fractions because they make me think of pizza. Yeah, pizza. You see, a fraction is a way to show a part of a whole. And a whole pizza is usually way too big for one person to eat alone. People usually eat just a part or a fraction of a pizza. I'll show you how it works with this pizza here. The pizza is cut into 4 equal slices. That means the whole pizza is now in 4 parts. If I eat 1 slice, that means I ate 1 out of 4 slices. That's written like this: 1/4. 1/4. I ate 1/4 of the pizza. The top number shows how many pieces I ate, just 1. And the bottom number shows how many pieces the whole pizza was cut into, 4. 1/4 is a fraction. A fraction is a way to show a part of a whole. Let's look at 1/4 again. The top number, this number 1, is called the numerator. The numerator shows how many parts you have. The bottom number, the number 4 in this case, is called the denominator. The denominator shows how many equal parts the whole is split into. And this line actually means division. The numerator is being divided by the denominator. That's a fraction. Let's look at another one. This is a fraction you might have seen before. It's called 1/2. What if I had a smaller pizza and I decided to split it right down the middle to share with a friend? It's only cut into 2 equal slices or parts. If I eat one of those slices, I've eaten 1 out of 2, which is 1/2. This top number, the 1, is the numerator. It tells us how many slices I ate. This bottom number, the 2, is the denominator. It tells us how many equal parts the whole was cut into. Uh-oh, looks like someone wants the other half. Sorry, buddy, I already promised it to someone else. Plus, pizza isn't for dogs. Yeah, maybe we can find you some dog treats, you know? What are you gonna do, right, Mr. Whiskers? Yeah, we should probably go back to talking about fractions. Okay, check this one out. This time, I'm cutting the pizza into 3 equal slices. If I eat 1 slice, that's 1 out of 3. That's called 1/3. 1/3. The top number, the numerator, is 1, because I ate 1 slice. The bottom number, the denominator, is 3, because the whole pizza was cut into 3 equal parts. I ate 1/3 of the pizza. You know what? I've had a lot of pizza here, all right? And I get it, okay? But may I please just get a carrot, okay? I need carrots. Please, carrots. Okay, I feel better. Now, you know how the top number in a fraction is called the numerator, and the bottom number is called the denominator? Well, I have a trick to remember that. When I think of fractions, I think of North Dakota. You know, the state. North Dakota. ND. It helps me remember that the numerator is on top, and the denominator is on the bottom. North Dakota. I hope you don't mind. You've helped me through the years with fractions. Thank you, North Dakota. The numerator is on top. The denominator is at the bottom. North Dakota, ND. That's pretty cool, you know? Okay. Now that we've seen how fractions work, it's time for a game. I'm going to show you some shapes. Each one will have 2 different colors. Your job is to figure out what fraction of the shape is red, okay? Look closely at each shape, count the parts, and try to say the fraction out loud before I show you the answer. Are you ready? All right, we'll start with a simple one. What fraction of this triangle is red? What fraction of this triangle is red? Yeah, 1/2. Half of the triangle is red. Great. The numerator shows us how many parts are red. Just one part is red. The denominator shows us how many total parts the triangle is split into. The triangle is split into 2 equal parts. Awesome job. Okay, what fraction of this square is red? Remember to count how many pieces are red, and then how many total pieces there are. What fraction of this square is red? 3/4. 3/4 of the square is red. Tremendous! The numerator shows us how many of the parts are red. 3 of the parts are red. The denominator shows us how many total parts the square is split into. The square is split into 4 equal parts. It's split into fourths. 3 out of 4 parts are red. That means 3/4 of the square is red. Very cool. You're getting the hang of this. Fractions. Whoa, that's a big piece. That's going to make someone very happy. Oh, it's not as big now. Okay. Well, that makes sense. That makes sense. It's just not as big of a fraction as I thought it was going to be. You know what? Let's check out another one. What fraction of this circle is red? What fraction of this circle is red? Yes, 2/3. 2/3 of the circle is red. Fantastic! The numerator shows us how many of the parts are red. 2 of the parts are red. And the denominator shows us how many total parts the circle is split into. The circle is split into 3 equal parts. 2 out of 3 parts are red. That means 2/3 of the circle is red. Great job. You know what? We only have 2 more. Isn't that great, ducks? Where are you going? You're swimming away? You're not even going to give them a try? Wow, I don't know. I thought you could practice fractions too. Well, maybe next time. Okay, here's the next one. What fraction of this rectangle is red? What fraction of this rectangle is red? Yes, 4/5. 4/5 of the rectangle is red. Awesome! The numerator shows us how many of the parts are red. 4 of the pieces are red. The denominator shows us how many total parts the rectangle is split into. The rectangle is split into 5 equal parts. 4 out of 5 parts are red. That means 4/5 of the rectangle is red. Wonderful job. All right, here is the last one. I know you've got this. What fraction of this circle is red? What fraction of this circle is red? Yes, 3/8. 3/8 of the circle is red. Very cool. The numerator shows us how many of the parts are red. 3 of the parts are red. The denominator shows us how many total parts the circle is split into. The circle is split into 8 equal parts. 3 out of 8 parts are red. That means 3/8 of the circle is red. You did an amazing job learning about fractions. A fraction is a way to show a part of a whole. The top number of a fraction is called the numerator. The numerator shows how many parts you have. The bottom number of a fraction is called the denominator. The denominator shows how many equal parts the whole is split into. And this line actually means division. The numerator is being divided by the denominator. That's a fraction. And now you've got some good fraction practice under your belt. Keep up the great work. You'll be a fractions master in no time. I'm so proud of you. You did an amazing job learning about fractions. You've learned a good bit, and there's still a lot of fun ahead. I think we're ready for the next topic. Now, you are about to learn about something that's pretty cool called probability. 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 Probability is the chance of something happening. That's pretty simple. Probability is the chance of something happening. I'll show you how it works using coins. Yeah, coins are fun. Especially to spin, okay? Look at this spinning penny, and it might look like the penny's alone. Don't worry, the penny has coin friends. Let's say you have these 5 coins, 3 pennies, 1 dime, and 1 nickel. You decide to randomly pick a coin to spin on a table. This is going to be a totally random pick. You aren't going to peek. If you randomly pick one of these coins, how likely are you to pick a penny? That's a good question. Well, more than half of these coins are pennies, so the answer is likely. You will likely pick a penny. Likely means there's a big chance. Okay, how likely are you to pick a dime? Well, that's different. There's only 1 dime. Only 1 out of the 5 coins is a dime. How likely are you to pick a dime? The answer is unlikely. Unlikely meaning there's a chance, but you probably won't. You are unlikely to pick a dime. Well, let's not leave out the nickel. How likely are you to pick a nickel? Well, let's think about it. There's just 1 nickel out of 5 coins, just like we had with the dime, which means there's a chance you might pick the nickel, but you are unlikely to pick it. The answer is unlikely. You are unlikely to pick a nickel. All right, here's another situation. Say you are at a baseball game and you found some pennies. 4 pennies, in fact. Just to be silly, you decide to randomly pick a coin in your pocket to see which kind you pick, even though all 4 coins are pennies. How likely are you to pick a penny? Well, you have to pick a penny, right? Because that's the only option. You are certain to pick a penny. The answer is certain. In probability, we use the word certain to mean there's no chance of anything else happening. You are certain to pick a penny, 100%. Now let's look at a completely different scenario. Say I want a green balloon because green is my favorite color in the whole world, which it actually is. I don't know why, it just is. Green has always been my favorite color. All right, so I go to a store to try to buy a green balloon, but I don't know they only have red and blue balloons. All the other balloons are sold out. How likely am I to buy a green balloon at this store? Well, there aren't any green balloons, so there is no chance. It is impossible to buy a green balloon from this store on that day. Impossible is the word used in probability when there is no chance of that outcome happening. I can't buy a green balloon from this store right now. It's impossible. I'm just kidding. It might be impossible to buy a green balloon from this store today, but there's no way I'm giving up. I can go somewhere else and look for a green balloon, or come back here another day once they get more green balloons in. Alright, so probability is the chance of something happening. There are words we use to describe the probability of an event. There's certain, that means you have a 100% chance. It will happen for sure. There's likely, that means you have a big chance. There's a big chance it will happen. Then there's unlikely. That means there's a little chance of it happening. And lastly, the term impossible, meaning zero chance. Just like there was zero chance of me getting a green balloon at the store that day. That does not mean it will always be impossible. In fact, the probability or chance of something happening can change. Maybe you find another coin at the baseball game, a nickel this time. Or maybe a delivery truck arrives and suddenly I do have a chance of getting a green balloon at that store. Okay, now it's time for a probability quiz. I need your help. Pretend you are at a movie theater. You've been picking up coins you found along the way, 7 in all. 4 nickels, 2 dimes, and 1 penny. While you wait for the movie to start, you pick coins randomly without looking. How likely are you to pick a nickel? How likely are you to pick a nickel? Likely. Correct. You are likely to pick a nickel. More than half of the coins are nickels. You have a big chance of picking a nickel. That means it is likely. You are doing great. All right, how likely are you to pick a penny? Penny. How likely are you to pick a penny? Unlikely. You are unlikely to pick a penny. There's a chance you could pick a penny, but it's just a little chance. Unlikely. What's next? Oh, how likely are you to pick a dime? A dime. How likely are you to pick a dime? Unlikely. Yep, you are unlikely to pick a dime. With only 2 of the 7 coins being dimes, there's only a small chance you'll pick a dime. Unlikely. Okay, here's the final question. How likely are you to pick a quarter? A quarter? How likely are you to pick a quarter? It's impossible, yes. If you only have these 7 coins, it's impossible to pick a quarter because none of them are quarters. It's impossible. But remember, if you find a quarter later on, add that to your collection and play the same game, the probability would change. It wouldn't be impossible anymore, but it would be unlikely. So, probability is the chance of something happening. There are words we use to describe the probability of an event. There's certain, that means you have a 100% chance. It will happen for sure. There's likely, that means you have a big chance. There's a big chance it will happen. Then there's unlikely. That means there's a little chance of it happening. And lastly, the term impossible, meaning zero chance. Just like there was zero chance of me getting a green balloon at the store that day. That does not mean it will always be impossible. In fact, the probability or chance of something happening can sometimes change. You did such a wonderful job learning about probability, the chance of something happening. I think Mr. Whiskers is likely to agree. No, he's certain to agree. 100%. 100%. Mr. Whiskers. Wow, okay, I got a little emotional there. Awesome job learning about probability. I think it's time to learn about geometry now. Geometry, that would be fun. First, let's look at lines, line segments, and rays. And then we can all clap, in celebration. I mean, look how happy this guy is, and he knows all about lines, line segments, and rays. Right, Bill? Right? Okay, he's doing his own thing. In math, a line looks like this. You have a line with two arrows, one on each end. These arrows show that the line keeps going on forever in both directions. A line has two arrows. Now, a line segment is so different. It has these two dots, one on each end. These dots are endpoints. It doesn't keep going and going. It starts at one point and then ends at another. This is a line segment. So here's a line. We know it's a line because it has these two arrows. Pretty cool. The arrows show the line keeps going and going in both directions, right? And what's this called? Do you remember? Yeah, a line segment. It has these two dots. They are endpoints. A line segment doesn't go on and on. It has these two endpoints. There's a beginning and an end with a line segment, isn't there? Now, what about a ray? What does a ray look like? Well, a ray is kind of a combo, a combination of the two. You can see it right here. A ray has an arrow on one end, making it like a line on that side, but a ray has a dot on the other side, an endpoint, like a line segment. A ray has an endpoint and an arrow. A ray is a combo, right? It has both. All right, so a line has two arrows. It goes on and on in two different directions. A line segment has two endpoints. It doesn't go on and on like a line does. It stops at the endpoints. It's pretty cool. And a ray has an arrow on one side and an endpoint at the other. That means a ray goes on in one direction, and then the other side just has that endpoint. A ray has both an arrow and an endpoint. Hey, I think it's time. It's time to unlock and discover a super trick. Something used by the true masters and legends of math. A trick you can use to discover if you are looking at a line segment, or a ray. Even this guy uses the trick. In fact, I think he may be writing me a letter right now. Dear Homeschool Pop, thanks for helping me with my math and for buying me these candles for my birthday. Okay, here's the trick. Just count the arrows and endpoints to see if you are looking at a line segment, or a ray. You might have picked up on that already. See, we already know that a line has two arrows, a line segment has two endpoints, and a ray has one arrow and one endpoint. So we count the arrows and endpoints to discover what we're looking at. That's pretty simple. Just count the arrows and endpoints to see if you are looking at a line segment, or a ray. That's the trick. You've been doing an amazing job learning. I think you're ready for a very special game of Tell Homeschool Pop What You See. Whatever you see on the screen, just tell me. That's it. That's the game, okay? Let's start with this one. What do you see? Yeah, a flamingo. Yes, this is a flamingo. Great. All right, I know, you were probably expecting something different, something related to this video. The thing about this game is you don't know what you will see next. Let's keep going, okay? All right, what do you see here? What is this? Yeah, a line segment. Fantastic! How do we know it's a line segment? It has 2 endpoints. 2 endpoints. This is definitely a line segment. Great job. Okay, what do you see here? What is this? A ray. Awesome. A ray. How do we know it's a ray? Yeah, it has an endpoint and an arrow. Very cool. Here is our last one. What do you see here? What is this? You've got it. A line. Sweet. How do we know it's a line? It has 2 arrows. That's right. It has 2 arrows. This is a line. Wow. I must say, I'm impressed. You did such a great job. You know what? I'm going to say it. I'm going to say it. You know all about lines, line segments, and rays. You learned so much. You learned this is a line. It has 2 arrows, right? A line segment doesn't have arrows, but has endpoints instead. And a ray has 1 arrow and 1 endpoint. That's it. Wow, this is a cute bunny. Speaking of cute, I better go feed Mr. Whiskers. Yeah, I better. Mr. Whiskers! Mr. Whiskers! Very cool. That was fun learning about lines, line segments, and rays. Great job. And I think we're ready for more. I think we are. The next geometry topic we're going to learn about is perimeter. Perimeter. This is going to be awesome. Imagine I'm a race car driver, right? And don't make fun of my car, okay? This is a perfectly good car to do a race in, right? It's very fast. It's got the bells, it's got the whistles. It's a great race car, okay? Stop laughing at it. Okay. Now imagine this is the race car course that I'm driving on, right? It's going around an oval. It's going around a shape. If I was wondering, how far is it around the track? What's the distance around the shape? Then I would need to know the perimeter. The perimeter is the distance around a shape. Wait. What is the perimeter? The perimeter of a shape is the distance around a shape. And it's easy to find. You can find the perimeter of a shape by adding all of the sides. That will tell you what the distance around the shape is. Great, now let's practice finding the perimeter. Look at this triangle. What is the perimeter of this triangle? Okay, first we need to know how long all of the sides are, then we can figure out the perimeter. With this triangle, all 3 sides are the same length. So how long are they? Let's pretend we measured it, and each side is 10 centimeters. Now remember, to find the perimeter of a shape, we need to know the distance around the whole shape. So we just add the sides together. What's 10 plus 10 plus 10? That's 3 tens. What does that equal? Yeah, 30. Awesome. The perimeter of this triangle is 30 centimeters. Remember, cm is an abbreviation for centimeters. 30 centimeters is the perimeter of this triangle. Okay, let's try this one. What is the perimeter of this square? First, we need to know how long all the sides of the square are. Then we can figure out the perimeter of the square. Okay, so this is a square. It has 4 sides, and all 4 sides are the same size. Let's pretend we measured it, and each side is 1 yard. Remember, YD is an abbreviation for the distance of a yard. Each side is 1 yard. Remember, the perimeter is the distance around a shape, so we'll need to add all of these sides up. Okay, what's 1 plus 1 plus 1 plus 1? Yeah, 4. The perimeter of this square is 4 yards. The perimeter, remember, is the distance around a shape. If you were to go around this entire square, it would be 4 yards. Okay, this is the final one. What is the perimeter of this rectangle? Well, first we need to know how long all the sides of the rectangle are. Then we can figure out the perimeter. Remember, a rectangle has 4 sides, and 2 of the sides are shorter than the other 2 sides. With this rectangle, let's pretend we measured it at 1 meter on the short sides and 3 meters on the longer sides. Okay, remember, to get the perimeter, we have to add all of the sides together. So we're going to be adding 4 numbers together again. To make it easier, we're going to group the smaller numbers together and then put the larger numbers in our equation. What's 1 plus 1 plus 3 plus 3? Those are all the sides. What's 1 plus 1 plus 3 plus 3? Yeah, 8! That means the perimeter of this rectangle is 8 meters. Wow, we told you it was going to be fun. Oh, it's such a blast finding the perimeter. The perimeter is so much fun to find. It's like a game. Remember, you can find the perimeter of a shape by adding all of the sides. And the perimeter of a shape is the distance around a shape. Wow, phenomenal job. That's perimeter. I hope you've had an awesome time learning. This video is almost done. We just have one more subject to talk about. It's from the world of geometry as well. Area. We're going to learn about area. That's right, area. Now, area is something we can discover about shapes. The area of a shape refers to how much space is inside of it. Area is very different from perimeter. If you'll remember, perimeter is the space around a shape. Area is the space inside of a shape. Alright, so area is the space inside of a shape, and perimeter is the space around a shape. So they're very different, aren't they? And this video is all about area. We're going to learn how to find the space inside of a shape. This should be fun. Let's play a game called What's the Area? We want to find the area of this shape. What kind of shape is this? Yeah, a square. Remember, the area of a shape is the space inside of the shape. We are going to measure the area of the shape using square units. So, the area of the shape is how much space is inside of it. So, how many square units are inside of this square? Do you know? If you don't, just count them up. Yeah, 4. There are 4 square units in this square. 4 square units is the area of this square. Okay, that was cool, right? Let's try figuring out the area of this rectangle. Just like last time, we are going to measure the area of this rectangle using square units. Remember, the area of a shape is the space inside of the shape. So, how many square units are in this rectangle? Do you know? Yeah. There are 5 square units in this rectangle. Great job! That's the area of this rectangle. 5 square units. Awesome. Now we are going to look at an irregular shape. What is the area of this shape? Just like we did with the others, we are going to measure the area of this shape using square units. How many square units are inside of this shape? Feel free to pause this video to give yourself time to count them. Were you able to count all of them? How many square units are in this shape? What is the area of this shape? Yeah, 12 square units. Great job. There are 12 square units in this irregular shape. So far, finding the area has been very easy because we've shown you the inside of the shape, so all you have to do is count how many units are inside. But what if you can't see the units inside the shape? What if there are just numbers that you know and you have to come up with the area another way? Here is the fun part. To find the area of a shape, you have to use multiplication. Yeah, multiplication! So, how do you find the area of a square or a rectangle using multiplication? All you have to do is multiply the length times the width to get the area. Here, we'll show you. Let's say we want to find the area of this rectangle. It is 6 feet long and 1 foot wide. Remember, to find the area of a square or a rectangle, all we have to do is multiply the length times the width. The length times the width is the area. It's just simple multiplication. So we would write 6 times 1. 6 times 1 will give us the area of this rectangle. What is 6 times 1? Do you know? Yeah. 6 times 1 is 6. Whenever you multiply a number times 1, it stays the same. So our answer is 6 feet squared. That little 2 next to feet means squared. It tells us that the rectangle has 6 square feet of space inside. The area is 6 feet squared. Why don't we try another one? Let's say we want to find the area of this square. It is 3 centimeters long on each side. Remember, to find the area of a square or a rectangle, all we have to do is multiply the length times the width. For a square, the length and the width are the same size, aren't they? Well, the length times the width is the area, so we just have to multiply. We would write 3 times 3. 3 times 3 will give us the area of this square. What is 3 times 3? Do you know? Yeah, 3 times 3 is 9. The area of this square is 9 centimeters squared. That little 2 next to centimeters means squared. It tells us that the square has 9 square centimeters of space inside. That was so cool. What about this rectangle? What is the area of this rectangle? As you can see, it is 4 meters long and 2 meters wide. Remember, to find the area of a square or a rectangle, all we have to do is multiply the length times the width. The length times the width is the area. It's just simple multiplication. So we would write 4 times 2. 4 times 2 will give us the area of this rectangle. What is 4 times 2? Do you know? Yeah, 4 times 2 is 8. So the area of this rectangle is 8 meters squared. That little 2 next to meters means squared. It tells us that the rectangle has 8 square meters of space inside. As we are wrapping up, we want to share 2 quick tips about area. As you saw from our examples, when you find the area of a shape, the answer is always squared. If we discovered the area of a shape was measured in feet and the answer was 50, our answer could be written 50 square feet or 50 feet squared. The answer is always squared because area tells us how much space is inside a shape. The little 2 means squared. The second thing we want to mention is that you have to use a different multiplication equation to find the area of circles and triangles. In this video, we just learned the basics of area and how to find the area of rectangles and squares, but this is just the beginning and the start of an exciting math world. There is so much more about area to learn. That's area. And you know what? That's it for this video. You just learned a ton of 3rd grade math. Congratulations, well done. In celebration, here's the beaver from earlier. I don't know, I can't give you a high five, so here's the beaver instead. You know your stuff. You know a lot of 3rd grade math. Wow, that's really something. That's really something. Hey, thanks for watching this video all the way to the end. Way to go! If you haven't subscribed to my channel and you had a great time, be sure to click that subscribe button for more learning. I have a lot of videos. I want to thank my patrons for making videos like this possible. It means the world to me. And thank you for watching. You are awesome, seriously. And hey, I'll see you next video.